Okay, so today we are doing another hard problem. Maximum fruits harvested after at most case steps. Fruits are available at some positions. They are given to the array. So position and amount. Ascending order, and they are unique, so there is not multiple of them at each position. Starting post integer k. You are at start pos. You can move left, right. It takes one move to move 1 unit on the k most steps. For every position you reach, you harvest all the fruits, and the fruits will disappear. Maximum total number of fruits you can harvest. Okay, that's interesting. Well, it's definitely not optimal to. My first thought is that we want to go left and then right, and that's it, or just left or just right, or yeah, that's it, because going left and then right is the same as going right and then left. We just want to pick the minimum out of those, because this, if you will go right here and then left here, that would take 2 plus 3, so 5 steps, which we cannot even do. So what I think we need, so that depends. So what we need is, okay, if I start from this position and I can only go right, how much will it take? If I start from this position, how much I can take, and so on. So if I move 1 here, then I can go k minus 1 here, or like k minus 2 minus this difference, right? Because I have to go left and then go back, left and go back, and then it's now depends on the coordinates, how large are the coordinates. So there is 10 to 5 positions. Okay. Well, we can notice that if we are here and we go here and then go right, we can only worsen the answer if there is nothing here. So we want to consider only going here and to the right, going to the, like going here to the right, going here to the right, and going here and to the right. Okay. Now, all we can notice is that, so one approach to solve this is that, okay, so first we start here, and in 4 steps we know we can get at this position, right? Like, how do we find that, how do we find the position with last position? So let's say, okay, what we want to do is we find out the range we can travel. Let's say we know the, like, we are not gonna go left of the current position, so we eat 7, and then k is 4, so we need to find some strawberries here. To do that, we just find the last position, that is, we go just through the position of strawberries or fruits and finish at the one which is still in the range. So in this case 7, we know, and we know the sum of this part with prefix sums. So we do cumulative sums, and then we do sum of this minus sum of this is sum of this. Now what do we do? Well, if we say that, okay, let's go one position to the left. Well, we can go only up until not 9, but we move 1 to the left, so we have to subtract 2 from the position we could go to the right, because we have k4, and if we go 1 here, we also have to come back and then go right. So 2 times this gap, which is 1, so we can only go to 2. We don't have to move this pointer, so we keep it here, and we get a cumulative sum of this. And then we move here, and then again move it by 2, get sum of this, and then move here. And then how much can we go? Well, we cannot go, we finish at the we can get back if we go. Well, we know this was the starting position, so we are at least gonna finish there. So we just keep extending 1, 2, 3, 4 up until here, and we get maximum is this. Now we have to do the same thing to the right also. Why? Because if we, like, let's say we wanted to try capturing those by first going right. Well, if we go right by 2 and back by 2, we lost all 4 and we cannot go here. Because remember, the first direction you go, you also have to come back. So ideally you want to go to the direction which is less, requires less steps. Or not ideally, optimally. So that should be the position, that should be the way to solve this. So let's start by first capturing the number of fruits, and we know the start position. So first we know the start position and the count weight. So first we wanna store the answer somewhere. Now if there is 10 to 5 fruits, and the counts of fruits can be up to 10 to 9. So even if we grab all, it still fits into int, which is great. Now we compute the prefix sums. So prefix of n plus 1 and prefix I plus 1, prefix I plus fruits at position I, and then the amount is the second element. Now that we have that, we can, let's first process going first to right and then to left, sorry, to the left and then to the right. So what do we need? Well, so okay, we just do iterations of doing 0 up to k and including steps. So now we are iterating over all possible options for jumping to the left. And actually that is irrelevant, because what we want to do, okay, this, I think I said that earlier, but we don't want to go by position, because testing this and testing this is just going to give us answer that is at most as big as, answer for this is going to be at most as big as it was for this, because by going one more step here, we lose 2 steps on the right, so we are definitely not going to eat more food, we can eat just less or the same. So actually we just want to try, we find the closest fruit to the left or at that position starting. So let's call L this, and while L is in fruits and fruits L position is more than starting position, we increase L. One last thing we need to do, if there wasn't an element equal to its position, we are going to, for example here, we would finish at this position. So that is interesting. That's a good edge case. For example, what if start position would be here? Can start position be outside of them completely? We could handle that edge case separately, But for now, let's code and we will see if we can handle it with the code or we just handle it separately. Or, you know what, let's handle it separately. So if start position is smaller than or equal to fruits, so can fruit be empty? No, it cannot, so we can rely on there being at least one element, so position is 0, then we just try to grab most fruits we can. So if fruits I is 0 minus, so we grab all to the right, in this edge case so if the position of the fruit minus the start position is less than or equal to k steps away, then adds plus equals fruits, so we get the amount of fruit. Okay, and I can actually this to the if, so and fruits I 0 minus start position is smaller than or equal to k. Great. And we return the answer, and then we do basically the same when start pos is larger than or equal to the fruits back 0. So the first position, I would personally prefer struct, because indexing, like instead of struct having a vector, is insane. That's very bad readability, but okay. Okay, and now what we want to do is we also need to add the same condition here. So if fruits I, so if start position, since now we are to the right of the fruit, is less than or equal to k, then we still do it. And then actually I don't need this. Fruits. Okay, so now we are definitely in between the strawberries. So what we found, now we came to okay, so we also actually now have at least 2 strawberries, and that are separated or free, that are adjacent to each other. Because if you have one, then we are at the left or to the left or to the right of it for sure. And if there are 2 adjacent to each other, then we are still to the left of all of them or to the right of all of them. So now we are for sure, like if we are here starting, no, that's handled. So if we are here and this one is smaller than us, okay, so we find the first one that is larger than or equal to us. Okay, and we want to do, if we are here, we actually, the first left one we are gonna grab is this. So if fruits L0 is larger than starting position, we decrease L plus plus. Now it's important to verify that even L is less than N and that L is actually larger than 0, because then we would index minus 1, which is non-existent. But due to handling these edge cases, our starting position is definitely between the first and last fruit. So we definitely are at most at the last strawberry and at worst we are, yeah, we have to be, we are not on the first, so we can subtract, and we are also not here. We are definitely on the last one because we handled that edge case here. Okay. So after we do that, I could check it with an asset to see where exactly it fails, but I think it will do a lot of bound the compiler, so let's leave it at that. Now, okay, so we got that, and then we know that. Okay, so we know that the first one to the left is this, and we need to find the first one to the right, which we can even capture from this position. So we start, we found first to the left or at our position. And then we go to the right, and so we can go, so we go here, and then we want to see how many strawberries we can grab. First edge case is that we cannot even go here if it's too far. I have to check that, so we only do this if fruits L0, so the starting position minus fruits L0 is smaller than or equal to k. Now if that is the case, we set the right index to r, and then while starting position minus fruits L0, so that's the going to the left, plus, and now fruits R0 minus fruits L0 is smaller than or equal to k, so we try to go up until index R to the right, and we go there from the left index. And if all of this, I can put it in brackets for it to be easier, starting pos, then we want to do R++. So now we are for sure at the first position, which we cannot reach. So answer, could we have computed answer? Not really. So the answer is prefix of R, since R is just outside of that. And we need to also do R is less than n. So prefix R, since prefixes are like the sum of first 5 elements is at the 5th position, not at the 4th, since we have the extra padding of the 0th element. Then, since R is the next option where it doesn't fit, then when we take like prefix, we'll have 4 elements here, 0, 8, 11, 17. And if we take prefix of R, so let's say we have left is 0, R is 1, or R is 2, like we can grab those two. Then, if you take prefix 2, which even though here it is index of the first invalid one, in the prefix array, it's just the index of this. And by same logic, we can just do L, since it's actually in the prefix array, we have to add 1, but this actually subtracts the other stuff we have here. So that's the first answer, but we can, I don't think answer is written here, but if I change the code and all notices, that's gonna be hard to find, so let's do that. And now what we want to do is, while L is larger than or 0 and fruits So if it's larger than 0 and then fruits L minus 1 minus start position. So if the next food we can get even on the next food, start pos minus this is smaller than or equal to k, so if we can even reach the next foot, okay, we go there, and then we have to move the right index. So while r is larger than or equal to L, and again this formula, so start pos minus fruits L0 plus fruits R0 minus fruits L0 is smaller than or equal to k. Or no, actually now we want to move until we are larger, so R minus minus, and now we want to see we are in a position where we at least can reach the left part, so we wouldn't go here. If k would be 2, we wouldn't even try this L. So R is at worst, we just move here. So you didn't see now at all what I did because I was pointing to my screen, but who cares. Okay, so now we have done that. What we want to do is ans is maximum of ans and prefix r plus 1 this time, because we are at the position where we can in fact reach it. So we can reach the left and the right one, so we have to increase this by 1, but we can keep L as L, and we subtracted L, so that should work. Okay, and now we want to do the same thing but reverse the array. Okay, so I have a little trick for that which I follow during coding. So let's have iteration of 0, 1, and what I want to do is at the end of the iteration we just reverse the fruits, but I also have to then recalculate this. So we have to recalculate prefixes, and I don't need them here, so I can just erase it. And we reverse fruits begin, fruits end. I don't actually have to compute this twice. I can compute it once and then reverse it to good point. So I reverse the fruits. I want to do the same thing. Just go to R and then do this, go to R and then do this, go to 3 to right and then left. So instead of doing all that, I just reverse the necessary things and that should work. So I reverse fruits and prefix and then I return answer. So let's see. Comparison, relational comparison unused. That's weird. What do you mean? So starting position is smaller than, so fruits back should be vector, and I just grab the first one of those. Relational comparison. What for statement? What are you yapping about? Fruits and minus 1, 0. What are you doing? That is weird. Fruits, start post fruits. I don't understand why this isn't working and this is, but I can actually also move this inside of this loop, because if we reverse it, then that's gonna work. Because if we reverse the array, so our no, that's not gonna work. Just reversing. Just reversing is not gonna work because okay, that sucks. So let's not just reverse. It's not gonna work because I'm gonna explain soon. So okay, let's start with, let's just wrap this inside of like a context. So int r is 0, or let's do n minus 1, and now while r is larger than 0, and fruits r0 is larger than start, false r minus minus, if fruits r0 is smaller than start, false r plus plus. Now if fruits, so what we do, we found the first fruit that is at our position or to right. Yeah, so what we want to do is that if the fruit's position minus the start position is smaller than or equal to k, then we set L to R while L is larger than or equal to 0, and so we go to the right, so start on fruits are 0 minus start position plus fruits, we go from right to left is smaller than or equal to k, L minus minus, ans max, ans prefix. We definitely can go to right, so first we have to do +1 and minus prefix L, I think, because L is at the first position where we cannot get, and R is still the position where we can get. So, okay. Now while R is less than N, R plus 1 is less than N, and fruits R plus 1 0 minus start position is less than or equal to k, then we want to do R plus plus, and while L is smaller than or equal to R, which is the same condition as there, and fruits are 0 minus start position plus fruits are 0 minus fruits so we go to right, and we go to right, that's this, and then we go from right to left, which is this. Is more than or equal to k, then we move to the left, and now answer is wait, no, it's actually larger than that, because we wanna, now we move to the right, so this might be too far, so we move until we can get there, and ans is max ans, and prefix of we can get to R, so R plus 1 minus prefix L minus 1, because we can get to L also. Or is it? No, it's the first position we can get there. Okay, we wanna, yeah, this might work. We'll see. What is the problem with this? Did I miss something, or what? If I erase it, what happens? fruits L minus 1 0. What the hell? Oh, I really typed 4. Are you kidding me? Bruh. Okay. So this says 11. Interesting. Let's check if it's not one of these cases. So let's call this the H1. And let's call this the H2. Okay, it's neither of those. It's the L, R, it's just some debug statements. LR inside. This is gonna be LR inside. Reverse. That's not gonna be LR inside, it's just gonna be LR reverse, and then this is gonna be LR inside reverse. Okay, so if I run this, so we can either go 0 to 1. Okay, that's weird. Where is that? So that's LR here. So you go to, that means that I go here and I don't actually reach this, so it's, I should also print the sums. Prefix R plus 1 minus prefix L. Minus prefix L. And then prefix R plus 1 prefix L. Let's see what's wrong with this. Okay, R plus 1L, R plus 1L, R plus 1L. So I grab 8 by going here, and then I'm LR reversed. Should be, I'm in the first position, which I cannot reach. So this should be L plus 1, I think. Okay, still doesn't work, so so if I go right, then I can go 1, 2, 3, so I can grab it. So 8, 3, 6, and expected is 9. Oh. Oh, I forgot about it. So because I go 4 steps here, and then left I can only reach here, so I ask only for this, but actually I can reach this because that's the... Okay. Okay, so okay, that's tough. So there is a bug that, okay, we first move to the right as much as we can, and then we shrink right. So not while this is this, but while R is larger than or equal, so while R is over L, and so what we want to do, well, we actually don't want to go until L is R, so while fruits so what we want to do is we want to not shrink the right side if we are outside, or so we wanna, when we wanna stop, we are moving the right position. And how much time do I have? 9 minutes. Yeah, I'm gonna figure it out. So now the problem is that I have to stop, like I am here, and left is also here, but if I move here, left should not move. That's in this case, but let's okay, let's solve it for this case. So while L is R and this holds the distance total is over K, I don't want to move to this, should be the case. So while L is smaller than R and this, so if I increase R, it's gonna be at most it's gonna be smaller than N, so L plus 1. So this holds true, it's larger. And what also needs to hold true is that fruits at L0 are smaller than or equal to start position. If I run this, that should work now. Okay, and now I have to insert the same thing inside of this loop. So this should hold, and the fruits R0 should be larger than or equal to start position. This should work, and that's just 2 pointers. Oh, and there is some thing very wrong. What is that? Use test case. Use test case. Boom. Something goes wrong. Runtime error. That's good, bruh. That is great. That is great. So let's say we get here. I am here. Okay, so we still get here. We get here. I am here too. No, we don't. So this is, wait. I am inside 1. I am inside 3. I am inside 2. Oh, I know what's the problem. This. Now it should pop. What? So inside 1. L R fruits size 8. How is R 19, bro? What the hell? If R n R minus minus, and also here I should make that if L0, L++, boom. Okay, they passed now. So some indexing error. I think. Let's see if there is no output now. Okay, let's try to submit. Okay, great, 40 milliseconds. Awesome. Well, that was a painful process, but let's try to hide it. So it's just 2 pointers problem. Keep the optimal solution is to either only go right, only go left, or only go left/right and then, or only go left and then the other direction. So optimal solution is to only go right, only go left, or only go left/right and then the other direction. Keep 2 pointers of reachable positions and use prefix sums to calculate number of harvested fruits in the currently reachable window. Notice that going, if there is a fruit at position I and not at, and next to the left of it is at position j smaller than I minus 1, then the answer is the same if we go first I position left and is the same for all k, which should be smaller than j minus 1. So j this I, this is Leetcode. So if we are inside, so that's, and what I'm talking about now is that we going to the left for a strawberry has the same answer as going to the left -1 if there is no strawberry. Then the answer is the same for all when we go k positions to the left first, since we can only lose fruits they are too far to the right. Therefore, we only consider positions with fruits. The solution is then straightforward. Compute the prefix sums and try to go to the first position to the left of start pos with fruits, then and calculate how far right can we reach, then how we can reach fruits from, then try to go to the previous, try to go to the next fruit to the left, and move the right pointer if necessary. Same thing has to also be done by trying all possible moves to right and then reachable moves to left, and calculating reachable fruits to left. We compute the O of n since we compute the prefix sums in O of n, and then move each pointer O of n times and do O1 work for each window. O of n since we keep the prefix sums. Okay, let's post. It's quite a small write-up, but solution is long because this is duplicate code, but it would be a little harder to fix. Actually, I mean, it might be possible. Maybe with, yeah, I'm not sure. Okay, so goodbye, see you tomorrow.